I will be turning off the music when I start actually doing some programming. Alright, I hope the volume's good right now. And so, okay, this is not what we're going to be actually doing. This is a ruse. That's actually an assignment that the second years have. And so I was teasing them with that earlier. Okay, so we have SpriteLib. Let's start doing stuff in SpriteLib. I don't know. I feel like I'm in a mood to make Snake right now, so I'm gonna try to make Snake. And so how I'd start that is figuring out what sprites we need for Snake. So very first one is the head of the snake, and then we can have a vector list of all of the parts of the snake. On top of this, we'll also probably need a body of the snake that we can repeat over and over, and the end of the snake, the tail. You know, maybe I should call these, reorder how these are called. So instead of body snake, snake body, it'll help out when typing, when I'm trying to autocomplete to the next one. If I just type in snake, I'll get all of these as predictions, and it'll just be easier to deal with. Yeah, we'll just we'll start there, and we'll figure out. I guess we can make some textures. So let's make a head of the snake. It's a yeah, it's a good enough size. Or you know what? We can make it a little bit bigger. Okay, can you guys still hear me? Just hope I'm not talking into a void right now. Okay, cool. Alright, so I'm not going to go too much into what I'm doing texturing wise, because the art doesn't matter for this. I don't care. I'm just going to name this snake body, and then we can not actually gonna make a different sprite for the head and tail. It's gonna reuse it for all three. So in our game CPP, we'll want to add these. And so what we can do is our snake head. It's going to be a new sprite. And the file name is going to snakebody.png. I think that's what I called it. Oh my god, the fucking backgrounds, I forgot about those. I better turn those off before a certain one pops up. Let's see here. Oh, I don't even remember where I set those. Okay. Ooh, that's a close call. Yeah. Okay, so we've got the snake head. What we can do is we can set its parameters. So the number of animations, it's going to be 1. The frame size, I believe I made that 128 by 128. So we give it the width and the height of the image. And it's not animated, so when it comes to the frame, it's just 0, 0, 0. The very first animation of this sprite is just start at 0, 0 pixels across the image, and that sets the first animation. Animation 0 is just a single frame at the very beginning. We can set the position of this. And so for the position, I'll make it close to where the other ones are. The center will just be its size divided by 2. Essentially, this is just setting the center of mass for this object when you rotate it. So 128 divided by 2, 128 divided by 2. So we want the head to draw kind of on top of the rest of the body, so I'm going to set the layer ID to, let's go with 100. Yeah. Oh wait, there's a function here. Ah, I see Hogue has added in like a default function for setting the center, so that if you don't specify an X and Y coordinate, it automatically determines the center by just getting the width and dividing it by 2. Very neat. Okay. And then, oh yeah, we can set a radius. And so our radius will be, if this is 128 by 128, we can make it 64. And I wonder if center X is like that. Ah, he's also changed the center to be more correct, to actually have an X and Y component. That's good. And so if we want to draw the head of this snake to the screen, we just add it to the draw list. So now if we run this, should have our really awful snake draw to the screen. And so yeah, right now it's just a sphere, but we can add the rest of him. And so the rest of him, we have our snake body, what we can do is make a temporary change to this sprite. We'll create a for loop, and we'll have our snake start out with 3 centerpieces, a head and a tail. So if we wanted 3 centerpieces, we'll just loop through this 3 times. And so we'll create a new sprite. We'll give it the exact same file name, so it'll look the same, but you know, we can change it later if we want to. Actually, if we tell it to just make a new sprite based off of the original snakehead, we don't have to set all of these again. If we want, we can set a new position so that it has the same position as before, the only difference being that maybe on the y-axis it's a little less every time. And so maybe 64. This way, yeah, like it'll inherit all the same values that this snake has. So the radius will be 64. We don't have to set it manually. We might want to change the layer ID so that they don't draw on top of each other. So this body temp set layer ID, we could have it be 100 minus I, and that way the further down the body you get, they'll be drawn behind. So kind of, you can think of it, it'll be drawing from the very back of the tail first, and then the first body part next to the tail would be kind of draw over part of the tail, and it would continue until it got to the head, and then the head would draw over the very last one. And then we can add these to the draw list for each one that we make. Yep. And then the tail would just be make what would we call it? Snake tail. To make a new sprite. We can base this one off of the very last part of the body, and I forgot an an important step is if we're keeping a list of all of these, what we need to do is also put it in that list. So we had our snake body vector list. We hover over this. Oh, snake parts. That's what I meant to call it. This is our list of the snake parts. And you can push back this body placeholder into this list, and then this list will have every single part of the body except the head. There's a reason why I'm not going to include the head, but actually, you know what? We might as well. So we can push that back to the as well. And so at the very beginning of this program, the snake parts list, and maybe I'll rename it to be a list so that when you're reading it makes more sense. And so actually there's a cool thing you can do in Visual Studio. If you hold Control R and then hit R again, you can rename a variable, and it'll rename it everywhere that you've put it in your code. So if I call this snake part list and hit apply, if we go back to our game.cpp, we can see that it already renamed itself, which is super convenient. Okay, so this list starts empty, and the very first thing that we add to it is the head of the snake. And then we loop through this 3 times and add each body part to it. And then for the tail, we can make a duplicate of the very last element in our list. So we can actually say snake part list dot back. Make sure to put the asterisk, and it'll get you the very last element in this list. And then we just say that we make a duplicate of it, put it as the tail, and then we can set the last few parameters. So like we can set its position to be 200 minus, and so if the position of this one is was it 200 minus I times 64, 192, 256, which will actually end up making it into the negative spectrum when it comes to the Y position. So what we can actually do is kind of raise the rest of the snake. We'll have the snake spawn at 500, 400 instead. So we have this tail, we set the position of it. We'll also want to set the layer ID so that it's at the very it's the last it's at the back of the image. I guess it's the best way to say it. And then we can add our tail to the end of the list that we can use for updating. And we gotta make sure that we also add it to the list for drawing. Otherwise, we'll have it in a list for updating, but we won't actually be drawing it. And that would be bad. Okay. And so with that, then if we run that code, you can see that we got our snake, and I messed up. Okay, let's see. I times 64. Plus 1. And wait, if I make this 300, is that better? Yeah, there we go. So what actually I can do here is I'll actually have I start at 1 and then go until it's or keep on going until it's no longer less or equal to 3. That way this I and this I start at 1, and the back of the first body part isn't at the same layer ID. So like if you were to look at these layer IDs, this is the front of the snake. Its layer ID is 100. And then this goes through this list: 100 minus 1, 99, 98, 97, and then 96. And so this is the tail. I'm gonna also don't need these 2 sprites, so I'm gonna remove those, and it's probably gonna give me some crashes if I try to run this again because they're probably being referenced in the rest of the code. Yes, they are. And so here's a really great thing that you can do is so if you ever get an error, you'll notice that you have like access to the stack frame at the top here, and you can use this to kind of find out where this error happened. So right now it just happened to be exactly where we wanted it. Sometimes it might be inside of a function and you have to kind of go outside of the code to find out where this function was called, especially for if you have a vector list and you go out of range. Maybe I can demonstrate that later if I kind of accidentally mess up. But so we're updating the test sprite, but we never, like, I removed the code that created it, so that's why we're getting this error right now. So if I go back to this update, and I'm just going to get rid of it, what we'll want to do instead is we can do a for loop we can loop through our entire snake part list here. Ah, okay. Alright, well, I can actually stop debugging. Will the stream be posted? The stream will automatically upload when it's done, I think. I won't be deleting it. Okay, so here we got a float DT, and this is our delta time, and I'm just sending it in here. I'm just putting it on a separate line so that our code's cleaner, and if there's any other update functions we have, we don't have to we don't have to write this part out again. We can just write DT. 2 letters is a lot faster to type out than this many. Okay, so now that we have that updating, just want to check what's going on in the update function here. Okay. Okay. So if I press any key, this is definitely going to crash. Oh, it crashed before I even got a chance to press a key. So there's more code here referencing the test sprites, and so I'm going to remove that. If we look at our keyboard down function here, we can see it also has this issue. So I'm going to comment those out as well. In fact, I'm just going to comment them out so that I'm going to end up kind of writing code similar to that, and I can just kind of reference it. So I'm going to be, where was it? I'm going to be kind of rewriting this, but working. Okay, so we have our snake, and our snake should be moving forward in the direction that we want it to go. And so to do that, you know, we can just set the velocity of the snake to be the direction it's facing. Okay, where should I put this? Somewhere in our update. I'm actually thinking now how I'd update the rest of the snake to have it behave correctly in terms of first year code, how I would write it. That is the tricky part. But we'll worry about just the head for now. And so for the head, we know that that is the very first element in our part list. So that would be element 0. And, or I think we can say begin, and then, no, doesn't like that. Okay, so snake, right, because begin gives a number, not the actual element itself. My bad. Its velocity will be equal to the forward direction of the snake. And so, if you remember during the tutorial, I'm going to kind of calculate that right now. Actually, this would be a neat function to actually put in our vector class, where it could create a vector from an angle. So I'm going to go ahead and do that. And so if we give an angle to our vector, I should say forward. And this will be equal to, we make a vector 3, what was it, negative sine f theta, and so sine f works in radians and SpriteLib works in degrees, so we actually have to make a converter for this. So if you want to make a converter, we can make a quick little function that does it. It doesn't even have to be a function, we can make a define that does this. And so I'm going to call this degrees to radians. And what this will essentially do, it'll be I multiplied by pi, or divided by pi, multiplied by pi divided by 180. And so we haven't defined pi yet, so we can do that too. Or wait, actually, if I remember correctly, I think that is it is defined in the code here, but I don't think we have access to pi from here. So you know what? I'm gonna define it again. In fact, I'm gonna actually straight up copy this code. Why not? So it's actually a good thing that so the way this define works right here is if pi hasn't already been defined, it'll define it. And so the reason why it kind of checks if it has already been defined is so that it doesn't define it twice. And so, yeah. Okay, so if I put this degrees to radians here, what's the problem with this? Oh yeah, gotta use the same pi, m pi. And so we have negative sine f. What else do we got? We gotta do cos f degrees to radians theta, and then on our z-axis we'll just put in 0. What is its issue with this? Argument types are float. Oh, I forgot a close bracket. Whoops. Okay, there we go. Yeah, we actually just return that value right there, and that'll be our forward vector. And then if we want to get to the right, I'm going to add a little direction to both of these. Then it's just theta plus 90 degrees. Easy peasy. And so the velocity is going to be equal. It's going to start out to be equal to. Okay, if this is starting out, I should put this in the initialization. The velocity is going to be equal to forward of so what is this? Should be a static function first of all, because we're creating a vector using a float. We don't use a vector 3 to create this forward direction. We're just using a single float to create it. And so then we can say vector 3 forward direction and then give it the theta of this same element. Theta. And so the velocity should be set for the very front of the snake. When this is done, oh, in our vector class, we're going to have to include math. Otherwise, these cosine and sine functions won't work. And all right. I believe the position is being set. Ooh, what do we have here? So this is a handy indication of why this stack frame that I drew attention to earlier is so important. And so it crashes right here. And we look at this and we're not sure what this is even happening here. We can see that an exception thrown, read access violation, and then it says this was, and it gives us some like garbage numbers. And so this is this is where in memory it's trying to read, but it can't. It never allocated this memory. And so if we go to the stack frame, we can see what ended up calling this function, or operator overload in this case. And so we can see that our add force function is what caused this error. And we're still not entirely sure why this caused the issue, but if we go even further down the stack frame, we can see there's our add force function right here, and we can see that it's happening on test sprite. And if we look at the values of test sprite, there we go. So we need to also remove this. Bye-bye. And so I do not believe the velocity is being set, so I need to do that. I mean, the velocity is being set, but it's not updating correctly. So if we go to sprite.cpp, we can see, okay, velocity, acceleration. You know what? Maybe this is probably what maybe the velocity is being set, but it's just such a small value that we don't see the change. So if we multiply this forward direction by like maybe, let's try 1,000, we'll see how it changes. And see, oh yeah, it went screaming across. And we see that all of them actually moved in that case. And the reason for this is because we set the velocity before this loop started making duplicates. So if we were to move this line after all of those and then run the code, we'd see that only the front moves now. Okay. So now if we want to add the keyboard support for being able to change the direction of the snake, here's what we can do. First I'm going to actually edit this sprite a bit so that we can actually see what the front of the snake is. And so I will draw a little forward arrow on this. I swear I can art. And then I'll just resave over that snake body image. And then, so I should be able to see the direction of them now. Okay, cool. So if you remember during the tutorial, I edited the options and input info. So what we can add is the inputs for when left, right, forward, and back are pressed. And actually for Snake, the actual version of Snake that I'm going for is, I'll see if I can bring up a video of it. Yeah, here we go. And so we can see that these snakes kind of let you change direction by letting you hold left or right. And it works the same as regular snake, where if you hit any body of your own snake or the edge of the screen, you die. And when you get these little food pellets, you get even longer. And some of these pellets move around and bounce around on the screen. So maybe if I have enough time I can do those too. Oh, purple sucks. And yeah, that's pretty much what I'm going for. Okay, so we're going to make some booleans for holding down left and right. So we'll have a bool left key and a bool right key. And we'll actually have to initialize these values at the very beginning so that they don't... when the game starts up, they'll either be true or false, and it's kind of random. So we'll have to make sure that we set them to 0 so that that doesn't happen. So in our initialized game, we had that input instruction, or struct, and so we can say left key is false, right key is false. Then, if we go back to our keyboard down, what we can have is when W key is okay. W, we don't care about W. What we want is A, which we usually interpret as left. We can say input dot left key is equal to true. And we can do the same thing for D, except that instead of the left key, it's the right key. And then for the keyboard up, we'll want to actually recreate these, only set them to false, because the keyboard up function gets called whenever a key is lifted. So we can't really tell if these are working right now because we're not using this boolean for anything. But what we can do is when we update, what we can have is our snake head, very first element, or the snake head itself, yeah, that'll also work. Its angle will be increased or decreased based on these two keyboard values. And so if input left key is true, then we'll want to increase theta, maybe. I can't remember if increasing the angle makes it rotate left or clockwise or counterclockwise, so I'll figure these out, and if it's wrong I can just reverse the operators. So theta will be plus equal to delta time, and then I'll multiply it by scalar. Ooh, the arrow keys? Yeah, let me look at this code. And so, okay, so here's what I'll do. I'll have it work for both the arrow keys and WASDA. And it's actually super easy to do it like this. So we'll need to duplicate these functions actually, and instead of an unsigned char, I believe it'll be an integer. And instead of keyboard down up, just call them keyboard special down and keyboard special up. And then if we go to where is it? I think it's in main. Yes, okay. In main, we'll also have to I'm gonna copy paste these functions. I'm gonna delete the comments because they're kind of doing the same thing, but keyboard, instead of keyboard callback function, these are going to be keyboard special callback function, and these will call the respective keyboard special down, keyboard special up. And so the reason why we have to make these functions is if we go back to game, we look back at this input function, there isn't a case for arrow key up. What it really is we have these keyboard, you can see glut has a keyboard function, and it's also got it's got a special func. And we're basically telling it which function to call with this. So you know pointers. Well, these are function pointers. So we have special special down, and then there's special up. So when the key is released, we'll want to call our keyboard special up callback function. So that's just these ones here. And then if we were to, we'll have to remake these functions. Keyboard special down, and so it's int key, int mouse x, int mouse y, and so it's very similar to the previous one. This is a switch, and then case. The cases are different in I believe it's glut key up, for instance, for the up arrow, and so we can say input dot, and so we don't want up, we want left and right. And we say input left key is true, and then glut key right, we'll set input right key to true. And our special up will be the same thing, except that instead of setting these to true, we'll be setting them to false. Okay. Yep. So if we have an input left key and input right key, so we can change this one to be right key, and then opposite angle it should turn. What we can do is recalculate its velocity, and so its velocity would be, we call that same function again, but this time we give it theta again. And so when theta changes, so will this also return a different number. And then we can multiply by a scalar so that the velocity isn't ridiculously slow. And oh my goodness, the rotation is a little wonky. I'm not sure what's going on there. I believe, though, I remember looking at his set center function, And I'm wondering if it's because of the position. Okay, no. I guess the best way to figure this out is to look at the draw function and see how these are being used. Ah, okay. So we have a center of the sprite. That's a different kind of center. Okay. So if we go to game.cpp, when we initialize this, we need to call both of these. The one for setting the sprite position, and there's another one for setting its position to be used for physics. So these two functions actually call set two different values. There we go. Woo! I'm trying to think about how to properly do this for you guys, for making the rest of the body move along with the snake. But you know what? For now, I'm not gonna worry about that. I'm gonna try to do the collision for when you collide with the rest of the snake. And so for now, say you're doing if you're doing snake, the very front, the head of the snake, you'd want to check against the rest of the snake for collisions, along with walls and maybe even other snakes, if you're doing multiplayer. The one part of the body you probably wouldn't bother with a collision check is the very first body part attached to the front of the snake, because they're already very close to colliding, and we might accidentally trigger a collision that we didn't want to happen. So, collision checks. Let's look at what's already written here. Is there a way to make it so that set center sets both values correctly? Yes. You know, we can actually do that now. In our sprite.cp, or I think it was in the sprite header, what we can do is just set both of these values in the same function. And so we can do the same one for the other set center, where we do it like this. Easy. And then in our name code here, we actually only really need one of these. Yeah. Cool. what's next? Yeah, we wanted to check collisions. And so okay, so we got a starter function for colliding. And so what this one does is it checks if a sprite is colliding with another sprite. And so this is actually very easy to kind of implement on the higher level, where you just, let's say, loop through all the parts of the snake. So we know that the head of the snake is part 0. We know that the next part is part 1. And we don't want to check if the snake is colliding with the part that it's already, like, should always be colliding with. Technically, you know, like if the head of the snake is cut off, it should really die. So like if there's not a collision, this snake should die if the head is cut off for some reason. But what we can do here is say snake head, what was it called? Yeah, is colliding with, and then check the rest of the list. And then we have a boolean at the beginning, is colliding, have it be false, and make it so that is colliding is equal to itself, or actually I think this is an operator that already exists. Yes. Alright, cool. Oh man. So this operator, so what this is essentially doing is it's a bitwise operator, and so it's checking if is colliding. If it's already false, and this is also false, the result is false. If the result of is colliding is true and is colliding is false, it gets set to true. If this is true and snakehead is colliding with is false, is colliding stays true. And so basically we want to keep this false until it finds a single collision. If it finds a single collision, all hell is going to break loose, and you know, the collision has happened. Although really, actually, we don't need that. We could just say, is it equal to, and then if is colliding, then we could exit out of the loop. In fact, we don't even need the boolean. If that's the case, we can just put that in an if statement. And no, wait, we do need to keep that reference so that outside of the for loop, if this is set to true, then dead snake. And for now, what we can do is print out collision. Okay, so we should probably start writing this function. So let's get to it. Is colliding. So you know, if we remember from class, it's just a radius check. If the distance between these two vectors is we should add that as a operator for our vector class. Get the distance between two vectors. I'm gonna make this static. So, you know, we subtract the vectors. It doesn't matter which order, because what we then do is we square it on each dimension. And so, actually, if we wanted to do that, we could just say if we had an operator overload for multiply equals, that would work. So I'm going to do that right now. And so multiply equals, you'll be multiplying one vector with right hand side, and so this right hand side basically be this at x multiply equals right hand side dot x, and we can do that for the y and the z. Then we need to add up all the x, the y, and the z. And get the square root of that. And then we can just return that value. So then we can say if the distance between the position, the center position of one object and the center of the other is less than both of their radiuses combined, so it would be less than this radius plus the other one's radius, return true. Otherwise, return false. And I forgot to close bracket. Yeah. Okay. Let's give this a shot. Oh, I think I know exactly what that was. Yeah. gotta return. Gotta return it. Alright, and so if we collision, and then it stops printing it out after the collision stopped. So and watch it happen here. Collision, and no more collision. Yeah. And so then if there is collision, we could subtract 1 from the snake, like snake's health. So we could, like, I don't know, we could declare that somewhere in game.h, like health of the snake. And then that snake, reset snake's position, subtract a life. Yeah. Yeah, okay. And so if we were to have the random objects around the map, it's really the same thing. It'd just be doing the same thing over again. Only not only would we have a vector list of like snake parts, but say if we had a bunch of apples on the map, let's say like apple list, and then every time you get an apple, it removes it from the list, as I showed in the tutorial, and you would check. You would check the snake head is colliding with, and then you would loop through the apples list, and so you could have like another boolean is colliding apple, and then kind of loop through that. If it does, then let me see, is colliding apple is equal to snakehead is colliding with apple listed I. And then if it's true, then add a point and delete the apple, or move it somewhere else maybe. So yeah, I think that's about it for tonight. If anyone's got any questions, I'll answer them right now before I end the stream. Alright. Well, I've got some questions that the second years are asking me, so I'll be ending this stream now. It was fun. See you guys